Let's continue our coverage of the rational class. I've added several functions to the rational class. The add, subtract, multiply, divide, compare to, and equals functions are added. And for example, the add function here receives a rational object as a parameter and adds this rational object to the calling object, the rational object that's making this call. The result of that addition is returned as another rational object. Same with subtract. Subtract receives a rational object, and this parameter received rational object is subtracted from the calling rational object, and the result is returned as another rational object. The calling rational object in all these functions is also called the implicit object, or the object that's making the call. So let's look at the implementation of these functions. I'm going to go to the implementation file and start by going over the add function. Adding two fractions, if you recall it from basic college algebra, adding a over b and c over d, the result will be AD, a times d, the numerator of the first fraction, times denominator of the second fraction. Add to it the denominator of the first fraction times the numerator of the second fraction. That's basically gives you the numerator of the result. And then divide it by the product of the denominators, BD. And the statements that you see here, the implementation is exactly implementation of this mathematical kind of expression. So the numerator is multiplied by second rational, that's the parameter, get denominator. So the numerator of the first fraction, that's a, is multiplied by denominator of the second fraction. So a is multiplied by d here, and added to that plus sign here that you see here is that plus sign in the expression that you see in there. Denominator of the first fraction, that is b, times numerator of the second fraction, and that will give you the c. Now in this statement, numerator and denominator refer to the numerator and denominator of the implicit object, the object that's making the call. And obviously the second rational dot denominator, get denominator, is the denominator of the parameter second rational. Now once this expression is computed, then as the returned value will create an asynchronous anonymous, I should say, rational object passing the numerator and denominator as parameters to it, and that rational object is returned. Same thing with subtract. There's the formula for subtract. This exact formula is implemented in the code, and at the end the numerator and denominator is turned into a rational object and returned. Multiplying two fractions, there's the formula. Here is the implementation. Numerator and denominator are turned into a rational object and are returned. Division, dividing two fractions is equivalent to multiplying the first fraction by the reciprocal of the second fraction. Notice that the second fraction has been turned over basically. And again, the implementation is implementation of the algebraic expression here, and the rational object is returned. The function compare to uses the subtract function to compare the two rational objects. Basically, the parameter second rational is subtracted from the implicit rational object, and based on the result, if the numerator is less than 0, basically if the result of that subtraction is negative, then the implicit object, the object that's making the call, is smaller. The return value is -1, and then if the result of that subtraction is equal to 0, then the two objects are the same, and if the result is positive, then the implicit object is larger than the parameter that was passed to it. Then you have the equals function that uses the compare to function, and if the returned value of the compared to function is 0, then the two rational objects are the same. Now let's test these functions. I'll go to source. I've already written a couple of lines of code here. Testing the add function. R1 calls the add function and receives R2 as its parameter. We add them. Remember, the return type of add is another rational object, so we'll just place it in add and then print add, turn it into string, and also we'll compare R1 and R2 and see which one is larger. So I'm going to run this, and the first three outputs are two string calls of R1, R2, and R3, and then here is the sum of R1 and R2, which is 10 over 33. This is R1 and here is R2, and we are adding them. So clearly the common denominator when we add them is going to be 33, 3 and 11, and then I would have basically 22 minus 12, which is 10. That's correct. And then comparing R1 and R2, which one is larger? R1 is positive and R2 is negative. So obviously R1 is larger, and we expect to have the return value of 1, which is correct.